And again, we thought what we would do is to sort of look at specific markers here. So if we take a look at the overall profile, it's I think fair to say that we have a mixture. So here we have a clicker question. Without knowing before, without the A priority, without your prior knowledge here, how many contributors would you say are in this mixture if you were just to look at this now? 2, 3, or 4? That's 1, 2, 3, not the number 2, 3, 4. Okay, I think we're getting close. So most people say it was a 3-person mixture. There's a certain percentage, a nice percentage that says that it could be 4. Okay, does anyone want to comment on that? I mean, it's okay. Looking at the mixture overall, do you see a clearly defined major and minor component here? Is there a clearly defined major and minor, yes or no? All right. I'm going to put the clock. You're on the clock. The New York Jets are on the clock. Okay. This is interesting. Okay. You have about a 56% split yes and the rest no. This is excellent. So let's get some discussion here. First of all, let's just quickly go through, are there stochastic issues? Well, yes, and a few of the loci. But let's go back here to let me ask, does someone want to propose why they think there's, yes, you can clearly see a major versus the minor contributor, or no? Does someone want to venture out? Steve, thanks.
I'd be willing to say that for most of the loci, except the very high molecular weight ones, which I would leave out of my stats.
Okay, excellent. Yes, so Steve says that yes, for many of the loci, you probably could pull out a major contributor. Am I summarizing you? But for some of them, no. And I mean, D3 is a good example. That 17 allele, I mean, we have a 14 and an 18 that are fairly within the same very nice peak height ratio there. But that 17 allele there could be a homozygote from a minor contributor. It could be just an extreme peak height imbalance between, the 14 and 17 with an 18. So in that case, we may not have one contributor who's a major, just looking at that one locus. But if you do look at the other loci, in some cases you can pull out one major Okay, does anyone else have any comments on that?
Didn't your question say major and minor, though?
For minor
Yeah, that
peaks,
probably-
that probably makes a lot of difference too, yeah.
I mean, some of us would have picked out a major, but not a major.
But not a major and a minor, that's right. Yeah, because I think later here, can you pull out a minor profile, the entire minor profile, or I should say profiles, can you pull out the minor contributors from the mixture? Yes or no?
Well, before we get to that, just to go back to, is this, okay. Just to go back to D3 really quick, where you're saying that there's a clear major there. I'm not sure there is a clear major at D3.
No, I think he said you can't.
Okay.
You
sorry,
can't be
yeah,
so
sorry.
sure.
So if you can't pull out a clear major at D3, does that put into question of whether or not you really are seeing a clear major at all the other loci? I mean, you've already said before you probably wouldn't pull out a clear major at the larger molecular weight because you feel like things may be dropping out. But if at one of the smallest loci, one of the most sensitive loci, you can't pull out a major, does that put into doubt for you whether you'd be able to pull out a major at the other loci?
Given that that's an isolated case within the low molecular weight loci, I would probably be comfortable in considering that 17 with the homicide of you, because it doesn't look like they're unrepresented peaks of contributing. And that would explain it in terms of definition.
But that 17, the 18 and the 17 by themselves could pair. I mean, that falls within, well, I mean, depending on, within our curve, it's a potential pairing.
That's a pretty low ratio for
It is. Yeah, I mean, the probability of that is low. Yeah. So, all right, I'm just throwing that out there to see what people think.
But yeah, it does make the point. You have to really consider it carefully locus by locus before you decide.
Right. Let me just reset this question here so we can ask. Okay, so do you feel comfortable that you can pull out the entire minor profile from this mixture, or profiles, or minor contributors from this mixture? Yes or no? Okay, we're up around 90, so yeah, so most everyone would say no. So let's take a look at some of these specific loci, and at least from a random man not excluded, yeah, I mean, as Steve said, with this one, this may be difficult to say that there's a clear major. We could certainly say that the minor peaks present are above stochastic threshold, and so if you are confident that all three individuals are there, then you could potentially use this for CPE. Todd, do you have your presentation on? Yeah, Chris, did you want to do any one of these? All right. D2, this is another example here where, again, as Steve said, we should probably look at locus by locus. Some of the larger molecular weight markers, you may not feel fully confident that you can find a clear major versus minor component. Does anyone have any thoughts on this as far as doing CPE on this particular marker? Looks like everything is above stochastic threshold. 2 clear major peaks there. So probably okay that everything's represented there. Yeah, the only concern here again is with these stutter peaks. So the stutter at 22 is, again, does this give you pause, as Devin said? Should we, if we consider that's a minor allele, it's probably below it's definitely below threshold. It's but definitely less than the 24 peak, which is at 159. So this is the place where you have to draw the line and decide how comfortable you feel.
Mike, what about the peak between the 17 and the potential stutter at 22? Does it pull up? Okay.
Yes. Yes, that's a pull-up, I think, from yeah. Okay, and then, again, here's another one, VWA. So we have what appears to be a major contributor, 17, 18. Another potential contributor we could claim, or at least show at 15, 16, but the 20 peak there. The nice thing about this is that, you know, the stutter peaks are really not a major issue here, and the 20 allele is above stochastic. So in this case, I would probably feel pretty confident or pretty comfortable using it for CPE. Okay. All right, so I'm going to turn this over now to Todd, and then John and Chris can also take a stab. Yes.
So would you use either TPOX or CSF?
So CSF, 2 peaks. We feel that there's 3 individuals here. Based upon the evidence that we've seen, there's probably 1 good major component here. Are we confident that both of the other contributors are within the 11 and 12? I wouldn't want to risk saying that. So it's uncertain with just this few information. I can't remember what John said, but I wanted to write that down. You know, when you have 5 and 6 alleles, things are, you know, sometimes straightforward. But once you get fewer and fewer alleles, you get 2 or 3 in a 3-person mixture, you know, it becomes extremely difficult. So I would probably not include that one. I don't know what I did, but okay. And which was what was the other, CSF and? Oh yeah. So well, TPOX. There's already at the 10 peak. There's a 141 RFU. So is that no? This is the. This is a different.
That's this.
I'm on the wrong mixture. Sorry.
It's the same situation.
Oh, it's the same situation. Okay, yeah, so TPOX, the 156, the 10 allele is above stochastic, but once again, I'm unsure if the remaining minor contributors are, the remaining minor alleles are all within 8. Based upon its TPOX, they probably are, but I wouldn't want to make that conclusion. So I would probably not use this locus.
Before you sit down, I just have a quick question about that. I've heard some people saying that in their labs they would not drop a locus even if they thought maybe the minor contributor had dropped out. And so I just hoped you'd go over the reasoning for dropping that locus.
Well, it comes to, and you know, just talking with Todd and others, it comes to the level of comfort, and do you feel that all of your minor alleles are there? Since we're not able to use the 2P or an F type designation with likelihood ratio, we could take that into account. But with CPE, then the question is, do you feel confident, just as Steve said, with some of these higher molecular weight markers where there's one really big peak, are you sure that there's not another peak that's at a 7 or an 11 that's dropped out? So
question I have is you're making these determinations without looking at your references, which is fine. But are you also taking into account any investigative information that you have? I mean, say this is an E-cell fraction from a pair of panties where the victim had consensual sex with her husband and then was raped by her brother-in-law, where you would expect overlapping alleles at several loci. I mean, are you taking that into account at all in real life when you're looking at these? Or do you just discount any investigative information you have and just look at it completely blind?
Right. Well, for this particular example, we didn't really have a scenario that we are applying here. But yes, you would take that into account in your, I think in the next one, we did make up a scenario. So you'll see what it's not quite the same scenario, but it's something similar. So yeah, I mean, you would take that into account, that type of, as to whether especially you can, well, not for CPE, but whether you can condition on individuals.
And I think for the likelihood ratio approach, that's absolutely implicit in the approach itself. You've got to actually set two hypotheses. So, have we got a person of interest, victim plus boyfriend plus unknown over victim plus 2 unknowns in this case? Or have we got victim plus 2 unknowns over 3 unknowns? Depends on the circumstances of the case, and it will make a difference to the likelihood ratio number, even if you feel confident enough about actually doing the calculation.
And that goes the same with random match probability. You have to feel comfortable with the assumption you're making. I mean, random match, part of the crux of that is you're making an assumption as the number of contributors. If you're not comfortable with the number of contributors, then you shouldn't be doing random match. You probably shouldn't be doing stats on that, and it makes the whole thing kind of difficult. So, yeah, you definitely take into account. For us, it's more of, hey, this house got burnt. We know he came in the front door, so we swabbed the doorknob, and we've got 6 alleles at every locus. I'm probably not going to feel comfortable that this is just a mixture of 3 people, because who knows how many people touch that. If they say it's a cigarette, or who knows, but I mean there could be some other circumstance where I'd feel much more comfortable that this is a limited population that could have touched us down to 3 people. Then I'd feel better about that.
I've got to go again.
And one of the big difference between RMP and RMNE is really with RMNE, CPI, you have to be confident that all genetic data is represented in what you're seeing. So, if you have 2 people, A, B, C, and D, you have to be confident that A, B, C, D alleles are all represented there. With RMP, random match probability, you just have to be confident that you have at least partial representation of everybody there. So if you have an AB with a CD, as long as you have like ABC, if you have a minimum of 3 alleles, then you're confident that you have at least partial representation of the 2 components, and that's what it comes down to. So that's why at the higher limits or the higher RFU levels, there really isn't that much difference between the RMP and the RMNE. But it's when you get down to the lower levels where things might start dropping out, that where CPI can't be used. You can still use the RMP because you can use that, under the assumption of however many contributors that you have at least partial representation of all components. Does that make sense? All right, sorry, reorient. So we're looking at 1 major, 2 minors potentially. This is where we kind of drop back and punt. I spent, back when I was, spent the last 1.5 years or so looking at RMP stuff, and just so people, if you know Stephen Myers, just so you don't think we're totally screwing him on working on this paper, he's actually one of the co-authors. So I learned most of RMP stuff from him, so I'm not going to go write a paper without him. So he's in that, hopefully that publication as well. But when we were looking at this stuff, I spent a long time putting together that Excel worksheet, and part of that time is writing out all the different combinations. I spent the better part of a day or 2 trying to figure out all the combinations of 3 alleles, or of 3 people, starting with 1 allele, 1 allele being present, 2 alleles being present, 3 alleles, 4 alleles, and then I just dropped back and punted, because there's no way someone's going to sit down and go through 100 different combinations to determine which ones are actually possible. So it really doesn't gain you that much information is what it came down to, and I realize that's kind of a wuss out of how to deal with this. But if we get a 3-person mixture, one, at our lab, we have to be fairly confident it's a 3-person mixture. That's a pretty rare event anyways. We also are going to have pretty good representation of these things. So for the most part at our lab, we only do this comparison and statistical calculation for a 3-person mixture if we have 5 alleles or more. Because at 5 alleles with a 3-person mixture, we're sure that we have at least partial representation of all 3 components. If it's a high enough RFU level, we're in the 500 to 1,000 RFU level across the board, we'll go down to 4 alleles potentially, but beyond that, and there's so many different permutations of that. But for the most part, we look at 5 allele and 6 allele loci with 3-person mixtures. So in this case, D3, we have 5 alleles. We also get away from the whole restricted aspect and we go to unrestricted. So we do an unrestricted RMP, which basically we're doing CPI. So we do D3, we'd use this as a CPI. Since it has 5 alleles, this is still a modified RMP, so we kind of get into this issue we were talking about before. But since there's 5 alleles, we don't have to worry about subtracting out the homozygotes because you can still have a homozygote genotype within that. And I don't know if I don't think we hit a 6. There's not a 6 allele locus that we're looking at here, but if we had a 6 allele locus, then it's basically the CPI with all the homozygote genotypes subtracted out. And that's the modified part of the RMP. But if it's 5 alleles with RMP and an unrestricted RMP, it's a CPI. But we just don't like saying we're doing RMP on this and then a CPI in that because you can't really combine those things. So we just call it an unrestricted RMP. Does that make sense? Cool. D2, wow, I wrote a lot. So here we've got that troublesome little 22 thing going on there. You have a peak in a stutter position, it's below stochastic threshold, but since it would be a 6th peak in an assumed 3-person mixture, you have no possible dropout. So if we made the assumption that, wow, this is a 3-person mixture, and I'm going to go ahead and make that assumption that allele peak, or that peak at 22 is definitely allele, then you've got all heterozygotes. And so you could do that and you subtract out all your homozygotes. The problem is, I don't feel comfortable that 22 is definitely a peak. So basically, this is the ultimate wuss out. This is going to be exactly like CPI, where I would take the 17. Let's see if I actually put that on there. Basically, I would take the 17, the 22, the 23, 24, 26, and 27, and do basically an unmodified, unrestricted RMP to CPI. So I'm considering all 6 of those as possible alleles in any combination of those 6, including the homozygotes, because if you think there's a possibility that 22 peak isn't an allele, then that opens up the possibility of homozygotes for the other alleles. Does that make sense?
Todd, I'm going to interrupt real quick. I know a lot of you are going to start leaving here in the next hour or so. Please don't forget to turn in your clickers or you'll be getting a phone call from me.
And just one more quick one. BWA, very similar to before. You've got 5 alleles. Again, all are above stochastic threshold, so at this point we don't have to worry about dropout associated with these things. If you have 5 alleles, if everything is above stochastic threshold, there's no possibility of dropout if you go with the assumption of 3 people. Because if everything's above, that means one of those peaks would have to be shared in order to have a part of that peak being associated with dropout. But if that's the case, then that dropout peak would be a 7th peak. So that, or a 7th, yeah, it ends up being a 7th peak. So you really can't have that in a 3-person mixture. So if you have 5 peaks in an assumed 3-person mixture and they're all above stochastic, you can't have dropout. So it ends up being basically the RMP is equal to a CPI. It's very similar to if you have 3 peaks in a 2-person mixture and they're all above stochastic, you can't have dropout associated with any of those.
So if you do that and say one of those alleles, oh, sorry. and one of those alleles is below threshold, your stochastic threshold, and you have 5 alleles, then how do you calculate that? Do you just do the 2p for that?
Yeah, you incorporate the 2p associated with that allele.
Do you worry about the homozygotes in that case, or no?
I would do that kind of ultimate wuss out thing where I would include the potential for homozygous in case there wasn't dropout associated with it. Yeah, we really, what we do with 2-person mixtures, I think we're moving towards using more of the data. We kind of fall back pretty far when we get to 3-person mixtures. That was it for that particular one. It's kind of less crowded up here. Is John going to do?
Did you want to do something?
Is this Sean's one?
Like this, D3
Yeah, sure. What,
or D2?
you just pick them.
Does anyone have would anyone like to see John do one of these 3, D3, D2, or VWA from a likelihood ratio? Does it matter?
Give me Sean's one.
Oh, you want to do that one?
Yeah, come on. Let's. I haven't taxed you guys hard enough. Sean one's close to impossible.
It's not as anonymous anymore. Sorry.
Oops. A person formerly known as Sean. What? I thought we'd picked one of these loci.
Yeah, it's. I was just giving kind of general idea.
Oh, can we go back to this general idea then?
Yeah,
So 1, 2, 3, 4, 5, 6. So there's 7 peaks, and we've got one big one and a bunch of little ones. And, I'm very comfortable with anyone who feels like closing this case down immediately and not doing it. So, I think we know something about this. Is that right, anonymous Sean? We have an owner of this item or something. Is that correct?
Not exactly. This is a homicide case. A fight broke out between the victim and a bunch of people. Ultimately, the victim was.
This was a homicide case where the victim got into a fight with a bunch of people in a park, and ultimately the victim was shot. Witnesses at the park say that they saw the shooter wearing a pair of black gloves. When the police showed up, the people in the park vacated the park rather quickly, and along the way of the path that they left the park through, they found a bunch of clothing. One of the pieces of clothing was a pair of black gloves, and this is the DNA result from the inside of those gloves.
Okay, all right. Let's have a go at it. So let's have a look at that locus. So we've observed that we've got at least a 4-person mixture. My first counsel to anyone doing this would be to not do it. Okay, but as I understand it, the deceased at the scene of the crime has bled extensively and is 15-15. So I'm not going to make you do this one because I think this one would destroy your hopes for the future. Okay, but let's just see, do we think we can do that? I don't even know if we can do that, but okay, let's say we've got a deceased at the scene, it's bled profusely, we've got some gloves at the scene, maybe we can live with that. I assume we have a person of interest. I don't know what that is just yet, but let's have a POI. And I think I need at least 2 unknowns, do I? Okay, now, as my second bit of advice, anything with 2 unknowns in the denominator is hard. Anything with 2 in the numerator and 3 in the denominator is very hard. So I'm going to show you just the technology of how to do it, but my advice really would be not to do it. Okay, I hope that sometimes we're just pushing things too far, you know. I had to do some cases for Melbourne, and I took them into someone, and they said, It looked like a mama duck with all the little baby ducks walking down behind it. And then, you know. So this looks a little bit like that as well, doesn't it? Okay. What do we think's in this mixture? Well, I think there's two 15s, aren't there? Not even trying to pair them up or anything. Of the two 15s, there's at least one 16, one 17, one 18, one 19. I'm not so sure about a 14. 1, 2, 3, 4, 5, 6. I need 2 more alleles. Okay, and I think in American speak, if I copy Todd, we call this wussing out. Is that right? So the wuss out equivalent is to throw in Fs. If you're not sure, you just throw in Fs. Maybe it looks like that. To be sure, if we're going to do this case, the 3 steps we've just done, the setting up the hypotheses and writing down this list are the hard bits. From here on, it's actually mechanical. Okay, I now reveal mysteriously, Mr. Coble, Dr. Coble, that the person of interest is ... Of course, it becomes a great embarrassment now if it's not in this list anywhere.
Let's say 15, 16.
Okay, we're going to say 15, 16. At least it's in our list. All right. A likelihood ratio is a ratio, so we put in this, and the top line has to have, so we can have the victim and the person of interest. So we've got to have a 17, an 18, a 19, and 1F. Okay? Now, why 1F? Because I've got a victim who's a 15-15, a person of interest who's a 15-16. I've got the 17, 18, 19. I've now got a tally of 7 alleles, and I've got to get to 8. So I put in 1F. Bottom line, I only got that 15-15 in there, so I've got to account for the 16, the 17, the 18, the 19, and 2 Fs. Just make sure I tally to 8. Just a quick check, who've I lost? Who's following? Who doesn't know how to vote? Okay, that wasn't so bad, actually. You know, this is such a hard case, I'd counsel not doing it. So really all I'm doing is taking the technology out for a walk. Okay, I'm going to crank it through. I've done this so often, I know that top line is 24. You've already just about done it often enough to know that's 24, is that right? F of 17, F of 18, F of 19. The bottom line, it is 360. Who said that? You can have a special sweetie reward, whoever that was. I can't identify you. That is 360. F of 16, F of 17, F of 18, F of 19. We get these beautiful cancellations. What's 24 over 360 is 15, is it? 1 over 15, F of 16. I bet that locus is close to valueless. All right, what's a standard frequency for the 16? I bet 15 times it is very close to 1. So I bet we've just done a lot of work to prove that locus is close to valueless. Anyhow, we took the technology out for a walk. Now, when I first introduced this technology to you, I did really ask you to realize that although you can do it, it doesn't mean you should do it. All right, and I kept borrowing Todd's nice little saying is that you cannot make chicken salad out of chicken dung. So yeah, I can apply the technology to anything, and in this case, we've got what I suspect is a valueless answer, and I would counsel not doing it. All right. I notice the class is disappearing. I'll take Michael's lead. I felt really warm about the way you guys waltzed through that slightly easier one before. I really felt you got that, and you know, I feel you could apply the technology, and I do pick up from you, you've got the judgment to know when not to. So I feel really good about that. So unless Michael tells me to do anything more, I'll sit down. You know, he's recording all this. He pushes a button and everything I've written goes into his slide. It's like, I can see this coming up in court against me sometime.
No, it'll be on eBay tomorrow, so. Okay, so let's take a little bit of time here, what time we have left. Again, we know that people are trying to catch flights, and so, again, as Debbie said, don't forget, leave your clicker. So the last example we have here is mixture number 3. 2 majors, 1 minor. So looking through the mixture, this is pretty apparent. We have more than 2 people. We have some loci like D3 with 5 alleles, so forth. So using your clicker, how many contributors would you say are in this mixture? 2, 3, or 4? 1 is 2. Okay, since we can probably say we have some attrition, we'll stop here at about 75, maybe. Yes, okay. Anyone else? All right. So yeah, most people agree that it's a 3-person mixture. This is a tricky one here. So do you see a clearly defined major or majors within this mixture, and a clearly defined minor contributor? Yes or no? Okay. No. So there's not a clearly defined major and minor. Just a quick look to see if there are any stochastic issues. Yes, at D7 we have 1 peak. It's in a stutter position at 91 RFUs. And then in the NED channel we have several peaks that are below our stochastic threshold. So some assumptions about this particular case here. When last night Chris and Todd and I were talking, and John, earlier in the day, let's assume that this is sexual assault evidence from the victim. She had 1 consensual partner before she was assaulted. So if you take a look at amylogenin, you can see that there's a major XY peak, and so what we're trying to identify here in this, we could assume then the minor contributor, let's say this is the sperm fraction from a differential, we have a very low level minor, which is most likely the victim, and we have 2 major contributors potentially here. So based upon that information, as far as proceeding with exclusionary statistics, do you feel confident here with D13, with this just as an example, that the 2 major components, maybe we want to do the CPE on the major components, so do you feel confident that the major contributors are represented here? Yeah. And so even with that 13 allele, excluding N+4 stutter, it's well above stochastic threshold. So if this is the victim, she's most likely homozygous here, or there's no little chance of dropout. For D16, again, once you start moving away from the 5 and 6, 4, 5, 6 peaks and 3 peaks here, how about this particular marker here at D16? Do you feel confident that the 2 major contributors are present among these 3 alleles? Brad's shaking his head no. Some people are saying yes. So, yeah, I mean, it's a little tricky on this one. So, do you want to comment, Brad? No? Okay. So, yeah, so it's difficult to say here whether we have a full representation of the 2 major components in this mixture. So this may be a marker that you would want to consider potentially not using in your stats.
Right?
Yes.
Before I would say that, I would have to look at the peak heights. And even if I can't see where the dropouts would be.
That's true. Yeah, so if you do consider the peak heights, so if you have a 911 and 1111, that makes sense. It's unlikely, I think, that if you have both major contributors as 911s, that's pretty unlikely. So even if you were to pair that 10 peak with either residual there, it does seem a little unlikely. So yeah, that might be worth considering.
I would probably document that in my notes if that was my reasoning, and I would do that.
Right. So as long as you document that and clearly explain what your theory is there, then it could be used. Yeah, this is one that's on the edge. D2, once again, we have everything above stochastic threshold. We have 5 peaks. We do have a little stutter peak there at 22. So what about this one? Do you feel confident that your major contributors are there?
Yes.
Fairly confident. So this would be okay to use for exclusionary stats. And then finally for VWA, again, this is one that I think I would feel pretty confident in using for exclusionary stats. That 16 allele is above threshold. Again, considering there may be a little effect from N-4 stutter and N+4 stutter, since it's between the 15 and 17, it is still above threshold. And so you could take that into consideration too. Okay, so I'll turn this over to Todd.
So we were given the victim's known profile for this, and so since the victim in this case is actually the minor component, the major, I would consider, I would proffer that the major is a mixture of 2 people. And so once you start going through this, and I'm not showing the other half of this, but just this was the last one I did this morning, so hopefully it's pretty close. But going through, looking at D13, if you look at that, you've got 4 alleles. The minor was a 12, the victim was a 12-13, so part of that 12 is coming from the 13. So you end up with basically 4, if you just look at the major component, which is a mixture of 2 people, make the assumption that the major component is a mixture of 2 people, all of those compare, so you end up with basically all combinations of those 4 alleles can go together. And so you end up having basically all genotypes of those 4. So it's all the heterozygous genotypes for the combination of those 4. So it's basically the CPI minus the homozygote genotypes. Yes?
If you were provided with a standard from the consensual partner, would you also subtract it out of the peaks that you have?
Yeah.
You would?
Yeah. Yeah. We don't get a lot of consensual partners with guns and bombs, so this doesn't come up a lot.
Would you also tend to use any of the information you might have in your non-sperm fraction as you're going about this? Or are you looking at your sperm fraction?
I haven't done a sexual assault case for about 5 years. I don't know. I haven't even contemplated that with RMP. I mean, it doesn't come up. The only time I do a differential is on proficiency once a year. So that would take some thought when I've had a little bit more sleep. D16, again, the victim here is a 9-10. Looking at the mixture proportions and everything else, I pretty much just scratched out the 10. Basically leaves you the 9-11. I feel confident with the peak heights that are available that both major components, you know, the mixture, the 2-person mixture major is completely represented. I don't think there's any any possibility of dropout. Excuse me. So you go through this thing. You end up saying it could be a 9-9, 9-11, or 11-11. And just to go back, I mean, that basically stems from, could be a 9-9 with an 11-11. Yeah, a 9-11 with an 11-11. So you end up with those, excuse me, those 3 potential genotypes. Go from there. Excuse me. Oh, thanks. Then D2, losing it. The minor component is the victim is 1726, so now you're left with 3 peaks for the major mixture. Go through the ones that seem to make sense with the mixture components, 23-23 with the 24-27, or the 23-24 with the 23-27. Yeah. And so you end up with those potential genotypes. So this is, I mean, this is our way of documenting kind of what we're saying is happening there. Then VWA, I believe, is the last one I looked at. Oh, there we go. There you go. Oh. All right, I did D18 too. Go me. Oh, D18, yeah, sorry. 12-14 was the minor in this case. So you take out those 2 fairly low level. Everything else is above threshold with the 2-person mixture. You've got 3 alleles, all above threshold. Things are getting kind of weird down here. So all those were, I've had those as potential yeses for the combinations. So you get all these potential genotypes that are possible contributors in the RMP. And even with all those potential genotypes, you're still at 8% of the population would be included as a potential contributor to that mixture. So, you know, even though you see 1, 2, 3, 4, 5, 6 different genotypes are possible contributors, you're still looking at 8% of the population as a potential contributor. So, that I believe is it.
Okay, well, that pretty much concludes the going through the mixture exercises. Does anyone have any questions or final comments that you'd like to make, or anything that? Yes.
Hi, Mike. The question I have is, like, in reference to your last example that we just showed. If that was not something where you're going to have a forensically valid assumption, what mass ratio would you guys recommend you'd use in order to separate out, like, a restricted CPI for 2 majors? And like, you'd be able to filter out your minor? Like, how much of a difference are you looking at? You know, where people say for a 2-person, you're looking at a 4-to-1, but now if you're talking about a 3-person, but you appear to have 2 majors, what type of buffering do you want with that minor?
Well, to be honest, I think in order to answer that question, it probably should do some validation experiments to take some
I knew you were going
known
to say
combinations.
That.
Because I don't have the answer right off the top of my head. So, but yeah, because there are additive effects, and
Sure.
you know, it's difficult to say a cut and dry. Well, if you're over 3-to-1, you're okay. But yeah, that would probably, in my opinion, I would do some quick little experiments to see what I would feel comfortable with at different DNA inputs too. Hey, Margaret.
If I look at the guidelines and they tell me what statistical methods I can use, it says I can use, you know, NRC, and it quotes those, and or other court-approved methods we've been looking at today. I doubt they're court-approved in my area. They aren't NRC. How does one approach those problems if you want to change your method? I mean, am I learning these only to find out I can't use them?
Yeah, that's. Does anyone in the audience have any advice on that? John?
I think likelihood ratio's got a general sanction in NRC too. Yeah, and
If I use your method instead of the one in Constat, am I okay?
I think it's the same.
I believe so. It's published and I don't know if it's court approved in your state, but it is in mine. But I'm sure, but I guess you may be faced with a Dobert Fry. I'm not sure.
So I would have to get, to do this, to make this work nicely, we would have to go through all the hearings. I would have to have some expert come in and help me get this report, but I just looked at it.
I'm so getting near the very edge of anything I understand here, but everything I've taught you in the last 3 days comes from basic principles of mathematics and a theorem that was laid down in 1763 and the core principles of molecular biology. So I'd argue I haven't actually taught you anything, right? It's just an amalgam of really ancient theory and modern genetics. Now, if you do have trouble getting it through court, I'm sure we can try and help you. Where is your state? Okay, I've never been to Kentucky, so that would be nice.
Well, I mean, part of the thing is, I mean, it says you can do X, Y, or Z or a court-approved method. It's not saying the X, Y, or Z have to be court-approved methods. So, you know, if NRC is recommending likelihood ratio,
Or a court-approved method,
right.
that's what it says.
But I think, I mean, likelihood ratios are addressed in there. CPI is addressed in there. RMP, I'd have to look, but
Modified one versus what NRC says. You see what I'm going? Is that going to have to go through all the trial, Daubert, all of this?
any method, it could have to go through that. If, you know, a defense expert, if a defense attorney wants to come up and say, I challenge the way you're doing things, I think any statistical approach could be challenged in court. So I don't think it matters what you're doing. I mean, you could be adding 1 + 1 and someone could challenge it. And, you know, I know one state just had to go through a Daubert hearing on swabbing. So it's, I think now with the NAS and a lot of things that's going out there, all judges are throwing rules out the window and just they're letting the defense challenge anything. So I don't think it matters what you use at this point.
So be prepared. In other words, when you change methods, you're just going to have to do it right.
Yeah, don't do it on the whim and just say we're going to switch to this tomorrow.
Okay, well, I think we'll end on a high note. This is something that I showed during my enhanced techniques, and I didn't have my animations working, so I thought I'd go back. This is the one I stole from Ray Wickenheiser, so mixtures from high quality, all above stochastic. That was easy, but when you have low quality DNA with alleles below your stochastic, man, you're winning. So thank you very much. I think I speak on behalf of all of the instructors, and I'm going to turn it over to Debbie.